Hey guys, so more distance coming up this week. So, what I'm going to be doing is just kind of again moving on a little bit. As soon as we come back from distance learning, which I suspect will be Tuesday, we'll have our stoichiometry quiz. Keep up to the snuff with that. We've been practicing and practicing and practicing. Hopefully, at this point, you're seeing mole ratios in your sleep. So, if not, if you're worried about it, again, just head to Kin Quiz, do a quick quiz, do 5 a night. If you did 5 a night between now and Tuesday, then you'll be ready. If you keep running into problems, send me a message. All right. Since we're in distance learning right now, it's a snow day. There's power outages. Admin has kind of suggested that we don't do synchronous in-person meetings, or not in-person, Teams meetings, because people don't have power. So instead, this is what I'm doing. I have a video that you can watch right now, and then you're also going to have 2 assignments, today and tomorrow, Thursday and Friday. Let's go through what they are. So the first assignment that you have, I'll give you an equation, and unlike this one, it has the products as well. You don't have to predict these products. They're all double replacement. All of them are double replacement. And both things in the beginning are aqueous, which means these salts are dissolved. The other ones don't have AQ on them, and they don't have S on them. They don't have L on them. They don't have G on them. You don't know what state they're in. You need to tell me if they're aqueous or solid. Okay? So, basically, are they soluble or are they insoluble? I put the solubility rules underneath it, so you can just run through those. Basically, just tell me, yes, this is soluble, this is insoluble. All right, so let's run through kind of what I want you to be able to do. Kind of by the end of this go through. So I have 2 things. I have barium nitrate and ammonium phosphate. Well, the first thing I'm going to have to do here is write out the formula for these boys. Now, I know barium is Ba. I know nitrate is NO3. Barium, I believe barium is group 1. Calcium, barium. Or is it group 2? If you're ever confused and forget these things, no, it's group 2. So if you can, feel free to look up on the periodic table. It's fine. This is group 2, so it's 2 plus. This is 1 minus. Swippy swappy. There's the formula. All right. Then we have ammonium phosphate. Ammonium is NH4 plus. This is 1 plus. Phosphate is PO4, and it's 3 minus, so I know it's NH4 3 PO4. There we go. And I know both of these are going to be aqueous. I know that because nitrates are always soluble, and ammoniums are also always soluble. Those are the 2 things that 2 rules that I really wanted you to kind of just know off the top of your head. Group 1's ammonium, nitrates, and acetates. Those guys are typically, or not typically. I never want to say always, because there's always going to be a weird exception. But these guys are going to be solubles. So they're aqueous. They dissolve. All right, and if this is a double replacement reaction, we swap the partners. So it's going to be barium and phosphate and ammonium and nitrate. And if we want to go through, so remember, first we flip-flop, then we start figuring out these coefficients. Barium is 2 plus, phosphate is 3 minus, so it's Ba3, PO4, 2. And this is 1 plus, this is 1 minus, so 1 and 1. Now, we balance. If we're balancing, we need 3 barium nitrates, which means we're going to need 6 ammonium nitrates, which means we're going to need 6 ammonium phosphates, and I'm in a loop now. No, we don't need 6 ammonium phosphates. We need 2 ammonium phosphates. 2, 3, 6 ammonium, 6 ammonium, 2 phosphates, 2 phosphates. There we go. All right. And I know this is aqueous, because we talked about it before. This is also aqueous, because we talked about that before. Now, this is kind of what I've set up for you. The question now is, in your assignment, what are these guys? Are these guys solids, aqueous? Are they both aqueous? Are they both solids? What's the deal? So I know right off the bat that all nitrates and all ammoniums are aqueous. So this is going to be aqueous. Aqueous and aqueous. Hooray! That's aqueous. These guys aren't. Barium and phosphate, these guys are going to be solid. And that's all I want you to do for the first assignment. Just say this is solid, this is aqueous, label it, move on. There you go. Now, Friday's assignment. Friday's assignment is going to be a little different. Remember, whenever we say something is aqueous, it means that it's dissolved. And when something is dissolved, it disassociates. So there's a different way that we can write this reaction. We can write it like this with everything together but aqueous, but there's a different way. And the way I want you to write it is with everything that can disassociate, all the aqueous compounds disassociated. So that means here we're going to have 3 barium 2 plus ions, aqueous, plus 2 nitrates, again aqueous. Now I said 3, oh no, it needs to be 6. 6. There's 3 barium nitrates, but 2 nitrates in every barium nitrate, so it's 6. Yeah. All right. And this is 1 minus. Okay. For this guy, I'm going to have 6 ammoniums, and this is 1 plus, and 2 phosphates, 3 minus, and this is again aqueous. Now whenever we get over here, this guy's solid, so it's not going to put out or it's not going to disassociate like that. It's not going to give off its ions. It's going to stay as a solid. So let's go ahead and write that as a solid. 2, and this is going to stay as a solid. These guys, though, are going to go ahead and separate out. And again, these are aqueous. Okay. So this guy is what I want you to write. It's not that bad. Basically, if it's aqueous, split them apart. Make sure you keep the numbers straight. So, you know, again, 3 barium and 6 nitrates. Everything should still be balanced, right? We have 2 phosphates, 2 phosphates, 3 barium, 3 barium. Everything is still balanced. So good, awesome, great. This chemical equation is now disassociated with all its ions. What we call this is an ionic equation. So this is an ionic equation. Now, I'm not going to go into it now, but I want to just get you thinking. If you have an equation in math class, and it's something really complicated like, let's say, a plus b squared plus 13 minus c equals a plus 3 plus c something plus d, let's say d. Okay. Now, one way that you can simplify this is, oh, hey, we have a's on both sides. I take the a, cancel them out. A's are on both sides of this equation, so I cancel it out. This is a math equation. This is a chemical equation. If something's on both sides, what do you think we can do? All right. So that is something I want you to just think about. We'll talk about it on Mondays. We're out of school. We'll talk about it later. I live hour to hour now. All right, guys. Have a good one. I will see you next time.